Hi, welcome to my second video. This is Maithili again. Now I'm going to explain about probability mass function. For a discrete random variable x, the distribution of x is defined by probability mass function. It's probability of x equal to probability of x equal to x. This function is called probability mass function. I'm going to move on to my next slide. The expected value is also known as mean. So E of x is expected value of x, that is equal to, we can define this E of x as summation of x into the probability mass function. This is the general formula for expectation of x. E of x equal to summation of x into P of x. This x is belong to that support. I'm going to move on to my next slide. These are all properties of expectation. So the random variable, if it is of the form ax plus b, the expectation of this random variable ax plus b, that is equal to a times e of x plus b, and expectation of ax squared plus bx plus c equal to a times e of x squared plus b into e of x plus c. I'm going to move on to my next slide. Now I'm going to define the nth moment about the origin. That is nothing but the expectation of x power n about the origin. That's why expectation of x power n equal to random variable x power n into the probability mass function. I'm going to move on to my next slide. Now we are going to define variance. Actually, variance is nothing but expected squared distance between random variable and its mean. That is called variance of a random variable. In terms, we can define this variance as sigma x squared equal to expectation of x minus e of x the whole squared. If we expand this, I'm going to get variation of x equal to e of x squared minus e of x the whole squared. I'm going to move on to my next slide. This is one small corollary related to variance. If x is a discrete random variable and a variance of ax plus b, that is equal to a squared times variance of x. That's it. I'm going to move on to my next slide. Moment generating function. In case the function g of x is equal to e power tx. We are going to define moment generating function x of t, mx of t equal to expectation of e power tx. Expectation of e power tx is nothing but summation of e power tx and its probability mass function. X belong to that support. I'm going to move on to my next slide. Expected value of g of x is called moment generating function of x. E of xn equal to mx nth derivative at 0. So this is mx nth derivative at 0 is nothing but dn by dt power n mx of t at t equal to 0. I'm going to move on to my next slide. In case the probability mass function p of x that is equal to is of the form e power minus lambda lambda power x by x factorial, that is Poisson. So moment generating function for this distribution, that is mx of t is equal to e power lambda into e power t minus 1, and mean E of x equal to lambda. Here I am explaining all the formulas related to probability theory. I'm going to move on to my next slide. So for that Poisson distribution, E of x squared equal to lambda squared plus lambda. I'm going to move on to my next slide. In this point, I'm going to stop this video. I'll continue rest of in my third video. Thank you for watching my video. See you. Have a great day.